Hello and welcome back to another day of Math 8. Today we're working on lesson 4. Today's date is September 24th, 2020. We're going to be working on making the moves, and the goal for today's lesson is that we're going to be able to draw and describe translations, rotations, and reflections. Our goal is to continue to make our vocabulary and our descriptions better and better and better every single time that we do that. This first activity was meant to challenge you a little bit by me showing you an image similar to this and having you take the opportunity to try and draw it. I'm just going to go ahead and draw it and talk to you about it here. The first thing that you would have noticed on here, this is going to actually be a reflection. And what we need to have in a reflection, there's some key components of every reflection. The number one component of a reflection has to be a line of reflection, or a mirror line as it's sometimes called. Every time we add another component to our drawing, we need to label it. I'm going to call this one line L, or the line of reflection L. And what we know about reflections is that those reflections have to come straight across the line. I still see a few errors with this one as I look at your homework, and that's why I want to review this one. Now, it might seem fitting that this image would just kind of come right over here, just flipping it around. I'm going to use my patty paper. And what I continue to see as people do these is I continue to see where people are reflecting them, but I see things like this. Now, the issue with this is that the line that's at a diagonal right here is this is not coming across the line correctly. And so what we need to be able to gather from this is why not. There's some certain rules that have to follow along with this. Under a reflection, corresponding points have to lie. So I'm going to write it down here. Reflection, corresponding points must be perpendicular. Across the line of reflection. Now, I understand that in the 7th grade math classes right now, you're talking about scaling and you've talked about corresponding points. So I'm going to review just briefly what we mean by corresponding points again, and make sure that we can use those same corresponding points to help us out. When we talk about B, the corresponding point of B when it's reflected is going to be B prime. As we look at this and we talk about having something that is going to be perpendicular, perhaps it would be helpful if we took our paper and looked at it from a position that we're probably more used to, such as a horizontal line. I understand that when a line is horizontal, then perpendicular, having an intersection of 90 degrees, means that I'm going to extend or take point B. Currently, it is diagonally 1 unit away from the line. So after that reflection, it will end up again 1 unit away from the line. This is where B prime will end up. I'm going to take a look at letter D. You don't have to draw these lines. I'm just using them for reference. Point D is going to come across. We see that there's 1, 2.5 diagonal units. I say diagonal because they're not the same length as these other vertical and horizontal. And so I'm going to come across another 2.5. There's half, 1.5, 2.5. Here's where D prime will be. And I'll do the same thing for A. There's 1, 2, 3, 4. 1, 2, 3, 4. Here's where we will see A prime. Once we have those figures, I want you to notice that each of these segments that come across connecting D to D prime, B to B prime, A to A prime are cut in half or bisected by this line. What we call that line of reflection as well is a perpendicular bisector, because it is perpendicular to the segments that would connect these, and it's bisecting them exactly in half. Once we have these 3 points, I'd like for you to turn this back up here, and then we're going to go ahead and sketch our shape. You'll notice that the shape is still the exact same shape. However, where we had it before, up and across here, is not in the same position, or however I had it. I think it was like this. Instead, what we see with this triangle is that we have reflected. I'm going to use this little segment right here to help me. We've reflected across line L, and we see that our figure is now the exact same distance away from the line, right? And it's in the same position with respect to where the line is. The only other piece that I failed to mention on here is we've also reflected the line, so we've named this line, whoops, L prime. Okay, pause it for a minute, review, think about these pieces. If you have a question about this, email me, send me a hangout, something to say. I'm still stuck on the reflection, and we need to work on that. The next part of the lesson is talking about naming some moves, or how we would name the moves that are happening. Before we do that, I want to talk about the vocabulary piece of this. And I want to review a couple things before we move on to that part of it. First off, what we're after with all this work all together is what we call the transformation. A transformation is the overreaching subject for all of this. Think about in English, when you make some kind of a concept web, we have transformation as the main topic of what we're talking about. Off of that main topic, we have specific evidences or key pieces such as rotation, reflection, and translation. These are the tools or the moves that we use to support transformation. Any one of these is a type of transformation, but we can also have several of them together. So when we talk about these moves or a combination of moves, we're talking about a transformation. When we do one or more of those moves, we're talking about a sequence of transformations. So one or more moves in a row is a sequence. When we want to talk about the difference between the original figure and its image, we have to use a little label that comes off of the figure that looks like an apostrophe. So our symbol that's like this is attached as in A prime, and we pronounce it as A prime. Okay, now to talk about each one of these different transformations, let's talk about translation first. A translation will always be described using 2 points. Must have those 2 points. Those 2 points tell us two different things. If we're talking about a translation moving from point A to A prime, it means it moves the entire figure the same direction, or the same distance and the same direction as the distance and direction from A to A prime. I've already kind of talked about that. The distance and the direction of the translation can be shown by an arrow, and that word that I've talked about is vector, or a directed segment. The way that we use the definition, or when we're going to talk about a translation, we have very specific things that we talk about. For example, use this sentence stem today as a helper for when you do your homework. We're going to look at this and say, here's a translation. Name the figure that you're actually moving. We can't say translate it, because we have to move past that. More precision of language. We need to say what we are translating. In this case, we're translating this figure, quadrilateral ABCD, that moves A to A prime. So if we're moving A to A prime, that automatically under a translation moves everything. So A, B, C, and D will follow that same rule. This line right here, or this arrow, is the vector that's telling us the distance and the direction that quadrilateral ABCD will move. The next time we talk about is a rotation. A rotation is described by an angle and a center. You have to have both of those. The direction that we're talking about is further described. So the direction of the angle is further described using clockwise or counterclockwise. So we have, again, those two things. We have a distance and a direction, or a magnitude and a direction. We have that angle measure that's off of a center, and then we have a direction, clockwise or counterclockwise. Again, pay attention to the notation that we are saying first the name of the figure, in this case, hexagon A, B, C, D, E, F. And I know you're looking at this saying, that's not a hexagon. Well, since it has 6 sides, it is a hexagon. That hexagon is rotated, here's our measurement, 90 degrees counterclockwise using center P. We can't forget any components to this, otherwise it leaves it so that there's some unknown information to make our description less precise. Finally, a reflection. We're taking that reflection and we have to describe every reflection with a line of reflection. So it's not enough just to say it flipped over a line, or it just flipped, or it reflected, because it is not going to cut it anymore. We have to talk about the name of the figure. So this figure, pentagon A, B, C, D, E, reflected across line M. Notice that the line is named right here as line M. The one thing that I would like to see you do when you do these reflections is understand that that line also reflects, and label it as a prime as well. These are the main concepts and main points of what we're shooting for today in our work. A couple of examples here. Let's start with this one. This is back on page 14. On page 14, we're talking about transforming figure A. I'm going to highlight these so you can see them a little bit better. Let's just talk about figure A to figure B. I'm going to show you some strategies for this. Hopefully you have some tracing paper that you can use. Tracing paper I used just a minute ago. If you don't have some, pause the video, go and find some paper, and let's trace these out. And when you're back, we're going to go ahead and trace figure A. And the goal is that I need to take figure A to figure B. Now I see that those two figures are already aligned the exact same way. So now I know that there's no rotation, and I know that there's no reflection. There's simply a translation here. So I'm looking at this translation that's going from A to B. In that case, I don't have much space down here, so I'm just going to put number 1. Figure A translates. Now see, we talked about how you had to have a couple of points. Over here we see, here is a translation of quadrilateral ABC that moves A to A prime. It will be helpful for us to add in a couple of labels. So let's go ahead and call this one, since we already have A, B, and C, let's call this one point D. And we'll just call the corresponding point, as you see it right here, this is point D now. The corresponding point right here, let's call that one point E. And now we have enough information to be able to translate figure A to figure B. We will say that by using a vector or a directed segment from point D to point E. We can say figure A translates or moves. We're going to use translates along vector D, E, and notice on the top of it we have an arrow, so it looks kind of like a ray, but we've named it vector DE. Another way that we can say this, so option 2 with this one, is we can say translation of figure A that moves D to E. That would be another spot because we're talking about, I guess I should probably put points, point D to E. We're very precise and very specific that there is no rotation and there is no reflection. The next part of it, we're still, maybe this is 1A, 1B, talks about how do I get figure B to figure C? Well, what we can look at with this one is we need to run some direction with this one and say, well, what's it going to take to get figure A to figure C? Well, clearly that's going to take possibly a translation. Maybe there's something else in here, a translation with a rotation. But as I'm looking at it, I actually can see that this one has a reflection in it. If I just fold my paper across the line, I can see that there's a line of reflection right here. So every line of reflection needs to be named. I'm going to call this one line L. And so we can say, going back, let's look back at our information here. Reflection is described by a line of reflection or a mirror. And with our example, we see the name of the figure is reflected across line M. We'll come back over here and we'll see that figure B is reflected across line L. And that would be enough. The last one we're going to do is look here at number 2. And then I'll talk to you, or I'll have another video to talk to you about the homework. What is one sequence of transformation that takes figure A to figure C? Now, if you're stuck and you're like, sequence of transformations, I don't remember what that means. I'll remember that it's in our summary. A sequence of transformations is when we do one or more moves in a row. So we want to figure out what move or moves will it take to get figure A to map onto figure C. And when I say map, what will it take to get figure A to do this, to map or fit right on top of figure C? Well, I think that I just showed you one of them. I think, when we get to it, if we just translate this straight down those diagonals, we see that they don't line up. But if we have some kind of a rotation in here, that will work. So it looks like the two things that I need to have with this, I need to talk about a translation. Oh, looks like I'm running out of lead. And I need to talk about, this is just for notes, a translation, and I need to talk about a rotation. Now you might be asking, well, does it matter if I rotate first or if I translate first? And the answer is no, it does not matter which one you do first. When we do talk about the translation and the rotation, we have to talk about how that happened. So I like to translate first, but when we translate, we need to translate to corresponding points. So earlier we marked this as a D, and as I translate down, I see that same point, if I look at this, has a corresponding point. Since I already named this one E, I'm going to go ahead and name this one F. So the first move that I'm going to make is I'm going to talk about translate my figure. When I look right here, translation of figure A that moves point D to point E. I'm going to go ahead and use that same type of verbiage right there, and I'm going to go translation of figure A moves point D to F out of here. And then my next move depends on this piece right here. I know that I need a rotation, but under a rotation, we remember that we have to have a center of rotation, we have to have a number of degrees, and we have to have a direction. As I rotate around that point, I can see that my rotation takes on one little bit. Remember that when we talked about these isometric planes, we talked about how every little angle in here is 60 degrees. If I'm looking at this piece right here and I'm turning, I'm just going to look at that little piece right there of this trapezoid. And I recognize that as I rotate, it's only rotating within that one little triangle underneath there that I just marked the angle in. What that will tell me is that my rotation is of 60 degrees. So I know that now my rotation is of 60 degrees. I'm just going to mark that so I don't forget it. I'm going to continue my sequence here. Translation of figure A moves from point D to point F. and then go back over to my sentence frame that talks about a rotation. I see a rotation says rotated 90 degrees counterclockwise, so I'm going to include the degrees. And then figure A, I'm going to say is rotated 60 degrees. And our direction was, let's see if I can get this, our direction was clockwise around center F. And that would be a fantastic description for where we're at. It also has to explain how you know. Well, with that sequence of how you know, you can talk about what you did. My strategy was to use the patty paper to bring it down to figure out what sequences you did. So I would say, how do I know? I would explain that I first identified the different transformations that it would take to get the figure A to figure C. I knew that it would be a translation, and then I knew I'd have to rotate it. And then I would talk about the other pieces of how I knew that I had to have a figure moving from one point to another. If you can explain those things to me, I'm going to be happy. So remember that as you're going through the lesson, remember that you have this information here. Remember that transformations include rotation, reflection, translation. These are all the types of transformation. Remember that we have to be very specific in our language. When we talk about a translation, we have to talk about from one point to another, no rotation within it. Remember that when we're explaining it, that we describe the name of the figure. We can't say it translated from A to A prime. When we talk about a rotation, we have to include the name of the figure, how many degrees, which direction, and where the center is. When we talk about a reflection, we must include the line of reflection. Hopefully this makes sense. Go ahead and go back and watch any part of the video that you need to. Remember, you can always reach out to me with an email